Flames are silent, but we can install ears for it with electronic components when a fire source is detected. It will immediately issue an audible and visual alarm. The transistor of 13009 MPN is the electronic switch of the entire system. IT is usually in the off state. Once it receives a trigger signal, it will quickly conduct. It connects the alarm circuit. It is the executive commander of the circuit. Then connect the 9-volt battery connector. Note that the red wire connects to the positive pole and black wire to negative. IT provides a stable DC power supply for the whole system. It is the source of energy. Then solder the N4007 diode. IT plays a protective role when the buzzer is powered off. A reverse induction voltage will be generated. This diode can bypass this part of the energy, preventing the transistor from being broken, which significantly improves the reliability of the circuit. Next is the 5mm LED indicator. Once the alarm is triggered, it will light up immediately, providing a striking visual cue which is convenient in noisy or bright environments. Quickly confirm the fire. In the LED circuit, we solder the first 1000 ohm resistor. Its function is to limit the current flowing through the LED, preventing the LED from burning out due to excessive current. This is the basic step to protect the light-emitting element. The buzzer is the sound alarm unit. When the transistor is turned on, the buzzer gets power and makes a high-frequency buzz. It forms a dual alarm of sound and light with LED, ensuring that no fire is overlooked. The infrared receiver is the core sensing element. It can detect the specific wavelength of infrared radiation. Once it senses the source of fire, its internal resistance changes, outputting a low-level trigger signal driving the transistor to conduct. This is the starting point of the entire circuit. Then solder the second 1000 ohm resistor. IT is connected in series between the signal output. Between the signal output of the infrared receiver, it acts as a current limiter and signal matcher. Protect the input of the transistor and ensure the stability and reliability of the trigger signal. Finally, attach a 9-volt battery. The entire circuit enters standby monitoring state. There is no flame sensor at this time and no output transistor, keeping the alarm silent and off. Now use a lighter to simulate a fire source. When the flame approaches the infrared receiver, the infrared radiation detected increases rapidly. The trigger signal is sent to the transistor through a resistor. The buzzer immediately rings. The LED lights up simultaneously and moves away. The flame alarm stops instantly, which shows that the circuit is responsive and reliable.